Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Dieckmann condensation. This is also an example of condensation reaction. See the statement. Intramolecular condensation of diesters in presence of base produces beta keto esters. What is the reactant? Diester. What is the product? Beta keto ester. This particular reaction is an example of intramolecular Claisen condensation. Already we know that Claisen condensation. In Claisen condensation, what happens? Two esters are combining together in presence of the base to produce beta keto esters. So two esters are combining. In case of Dieckmann condensation, what happens? Two ester groups available in the same molecule. Here in two molecules ester groups are there, but in this case what we are observing, within the same molecule if you have two ester groups, that is commonly called as diester. Diester involves in the condensation process to produce beta keto ester. In case of Claisen condensation and the Dieckmann condensation, products are same, beta keto esters. But the thing is that in case of the Dieckmann condensation, the products are cyclic beta keto esters. What is the difference? Cyclic beta keto esters formation takes place in Dieckmann condensation. How the things will happen? Let's see the equation. See this one. C double bond O C2H5 CH2 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 C double bond O C2H5. For your understanding only I have written this molecule in this form, otherwise we can write in this way. C double bond O C2H5 1 2 3 4 CH2 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 C double bond O C2H5. This is a ester or not? So two ester groups are present, that's why this is commonly called as diester. These kind of the diesters involving in the condensation in presence of a strong base, sodium ethoxide, like that, they can produce cyclic beta keto esters. Already we know that the mechanism of Claisen condensation, the mechanism is very much similar in this case also, but the thing is that here the things will happen within the molecule. That's why this is called intramolecular. This one is intermolecular. Inter means two esters we need to take. Intra means within the same molecule we are doing the reaction, right? So see the mechanism. Initially what is happening? If you see this ester group is an electron withdrawing group or not? That's why this carbon is acidic in nature or not? So carbon is acidic carbon means we can easily remove the proton from that carbon or not? That's why the sodium ethoxide is initially removing a proton from this particular carbon, thereby creating the carbene ion. The carbene ion involving in the resonance for the production of the ion which is containing O minus, that is commonly called as enolate ion. The enolate ion again form the carbene ion. Here C minus will develop. The C minus is attacking the carbonyl group of the second ester. Thereby what is happening? See this. The link is forming between these two carbons or not? That's why cyclization phenomena takes place or not? 1, 2, 3, 4, 5. 5-membered ring is formed, right? Here carbon attached to OC2H5 and oxygen. Oxygen charge minus. O minus OC2H5. In this way. O minus and OC2H5. Here at this carbon C double bond O OC2H5. C double bond O OC2H5. So in order to satisfy the valency of the oxygen, what is happening? Again the C double bond O formation takes place, thereby OC2H5 removed in the form of OC2H5 minus ethoxide ion. Already in the solution we are having H plus ions or not? So ethoxide ion combined with H plus ions to form ethanol or not? So thereby we have developed beta keto ester. Simply what we are observing? Hydrogen from this carbon and ethoxide from this ester removed in the form of ethanol, C2H5OH. Cyclization phenomena takes place. In that way, you can easily remember the Dieckmann condensation. Okay. Let's see some of the examples which are related to this particular named reaction. Here, see this molecule. At one end, we have C double bond O C2H5. Another end also C double bond O C2H5. So now what happens? Hydrogen from this carbon. Why? Because this is the acidic carbon. Hydrogen is removing. From the ester, OC2H5 is remaining. Simply what is happening? The bond is forming between these two or not? See this C double bond O C2H5. Simply elimination of the ethanol takes place. Here see this. Always in Dieckmann condensation, what should we have? Two ester groups at the terminal positions, commonly called as diester. Okay. Here see C double bond OMe. Here C double bond OET. Okay. Here the adjacent carbon doesn't have any acidic hydrogen, but here we have a hydrogen. That's why hydrogen from this carbon and methoxide ion from this carbon removed in the form of methanol to produce the corresponding cyclic product. Similarly, COOMe. Here there is no acidic hydrogen, but here acidic carbon is present. That's why acidic hydrogen is available. So methoxide ion from this carbon and hydrogen from this carbon removed in the form of methanol and produces this kind of moiety. If this is involving in the ketoenol tautomerism, you will come up with this kind of moiety. So very simple or not? Simply elimination of the simple molecules. Okay, so in this way we can convert the diesters into the corresponding beta keto esters. Simply the Dieckmann condensation is an example of intramolecular Claisen condensation. Okay, thank you very much.